So, started with who we are. So, I'm Nick. I've been at Viam for about a year and a half now. I'm a senior dev advocate here, and before joining Viam, I had been more of a hobbyist, a tinkerer, doing a lot of stuff on the side, working as a web developer in the past. But then found Viam, being an opportunity to combine my interests and to make that a professional life. And I gave Adrian some time to introduce herself as well.
Hello, everyone. Yes, I'm the newest senior dev advocate. I come from, I've been a software engineer, fell accidentally into dev advocacy because I enjoy teaching these types of developer concepts to everybody, really. And this is pretty much a dream job for me because I've always wanted to work with robotics. So very excited to be here, very excited to be with you all. And one day I will be taking this workshop off of Nick's hands, maybe. But Nick is a great instructor, so you're in good hands.
Thanks, Adrian. So, some of you know what Viam is because presumably you applied and you read about it and or have been here for a little bit as well. But for those of you who don't know, you don't need a lot of stuff to create what we call a robot. And we're trying to move away from the term of like classic robotics. People think of like industrial arms or mobile rovers. It's really the thing that makes a robot is taking in sensor information, data from the physical world, and then applying it in some way and actuating something out of that. And so you can start with something as simple as Raspberry Pi, which we have here, which is a nice off-the-shelf computer. It's a full computer. It can run a desktop operating system. It has USB ports, Ethernet, it has headphone jack. You have all this sort of stuff available in this tiny little package that you can embed in things like a keyboard. You can embed it in devices out in a field somewhere running a camera. You can run it all sorts of places. And it's still running a full operating system. You can do a lot with that. And combining that with the GPIO, which we'll cover soon on these pins, allows you now to connect even more to the physical world than you could with your laptop, because you don't have access to the raw, general input output that we have available to us on the Raspberry Pi. And when you combine that now with Viam, you get even more access and more intelligence out of the box. So as I mentioned before, what are the aspects of a robot as we look at them? We have sensing, so we're gathering data from the environment, from the physical world. A sensor could be a camera, and that gives you a lot of information. We talk about a picture is worth 1,000 words. Well, an image gives you a lot of data from it. It's just making sense of that data that gets to be the hard part for that type of sensor. We also have sensors in terms of humidity or temperature. Today, we're working with moisture and finding out how much water is in whatever we're trying to sense from. It can be, again, we have power sensors, we have movement sensors, it goes on and on and on. And we're gathering that data, you're reading data from the physical world. And then actuation is then taking action upon that data. You're going to either move a motor based on some movement sensor, or you're going to activate a water pump based on moisture to let more water in, or you're going to be actuating something, could even be in the digital world. You could be sending a notification, you could be running something, showing a UI in your web application or your mobile application. And then control is taking those two pieces together. So your control loop, your control code will take in data from a sensor and then actuate based on your logic built around that control loop.
Can we get a copy of this deck?
Yes, yeah, you'll have a copy of it.
Thanks.
If you have any questions at any point during this, just feel free to call out, let me know. And so what is Viam in this whole situation? So we're an engineering platform that allows you to pull in data from the physical world, add some intelligence and AI to it, and even automate how that goes out into the world and be able to deploy it, monitor, manage it over time, and allow you to use your skills as a software developer or a data scientist and apply that now more to the field of robotics and hardware and embedded. And the way that Viam does that is by creating an abstraction layer over the individual complications when dealing with physical components. So rather than having to know the API way of programming with this specific moisture sensor that I have here, or this specific relay that I have here, or a certain type of camera or a certain type of motor, again, all these sort of things may have different ways of communicating, but by Viam creating a simple API over top of all of that, you can change out those hardware components. You can change out the brains of it, the computer, and allow you to still use your same application code, the same logic that and apply it to whole new different types of hardware. And that also makes it easy for prototyping. So you can get started with something, again, like the Raspberry Pi or even on your laptop, and then maybe move up if you need more resourcing out on the edge, or if you're creating some type of custom hardware, then apply it there. So sometimes we have people using the NVIDIA Jetsons are becoming very popular now for heavy machine learning tasks. You can get started on something like this that's low cost and you can run your desk and then apply it out onto those big production hardware systems, or even a massive server up in the cloud if you wanted to. And then you can, because we create that abstraction layer, it allows you to use the language of your choice to program against VM. You can use, we support Go, we have Python, TypeScript, Flutter, Java, a bunch of these sort of things, and we can apply to many more based on the way we've architected it as the need comes around. And it's also open source, so then if you want to build your own version of that or build your own language support, you can. It's available for you to do that. And so why are we building this project with VM? To be honest, you could automate, you could have this running without using VM at all. But the advantage you get by using VM in this process, you now get to monitor remotely from the cloud. So if you're setting this up at home and allowing you to now go off on vacation and make sure your plants are still staying alive while you're gone, or keeping an eye on how they're doing over time, and be able to track that data and capture it and use it for more, like maybe during certain seasons, you want to track and say, like, okay, well, actually we need more water, so I'm going to tweak my algorithm a little bit. Or even be able to test new types of hardware without having to completely, again, refactor your code. And then maybe you want to add in more components to it that would be harder to do if you didn't use VM in this process, because then you're starting over from scratch sometimes, or having to completely refactor everything in terms of like, I want to add a camera node to add some computer vision, or I want to add in a moisture sensor. So be able to make this configurable and modular is a key part of using VM for this whole project. So hopefully you all went through the pre-work. You hopefully have a VM account. If you don't, now's a good time to get started and sign up. Okay. You can log in with Google, which makes it easy to just automatically create a VM account. And then you don't need an ID for this. An integrated development environment, for those who aren't familiar, is basically an editor for code. But you do need the Raspberry Pi Imager application. And I sent a link to that this morning, that shared group DM. And so the materials we're working with today, while you are getting started on that, is we have our Raspberry Pi 4, which is this single board computer that we have here. And it's called a single board computer because it's everything on one little circuit board there. Versus if you were to look inside your laptop, there might be multiple boards inside of there, multiple different chips that run the entire computer. You should have an SD card or micro SD card with somewhere between 16 and 32 gigs of RAM on it, or sorry, storage. And some type of reader for it. If you don't have an SD card reader, I have a couple here that you can use. We'll also have a 5-volt power supply that looks like something like this. And so this is just for powering our Raspberry Pi. And it has certain power requirements because that's what the computer requires. But you don't have to use this specific one if you're going to create one in the future. You can find one that just has the right power requirements. Thankfully, Raspberry Pi just sells to them. And then we have a 3 to 5 volt mini water pump, which looks like this. And so this is how we're going to be taking water from a cup and putting it into another cup. And so this runs off again like 3 to 5 volts, and we'll be going over how that works a little bit later. We got some silicone tube, so we can actually direct the path of our water, connecting that to our pump. We have our soil moisture detection sensor, which is a combination of both this sensor with these two legs here, as well as what we'll call the sensor module. So this connects from here to our sensor module, and the sensor module to our Raspberry Pi, and we'll go over why that's the case in a little bit. But these should come together in one bag, along with a set of wires to connect to the sensor with the sensor module here. And then we have a 5-volt relay module. So relays, we'll go over this a bit more later. It's just a way of switching power. It's basically like a light switch of sorts, or even a lamp switch. And we're going to control this. Jumper wires, sort of assortment of them to look like this. You have just enough to make this project work. And I have spares if we need to later on. And these are just way for, again, running electricity between different components. We have various sorts of them that we're going to call innies and outies. Any fans of severance in here? And so the outies are the one with the metal sticking out, and innie is the one without the metal part sticking out. You'd be able to connect together. So we have multiples of innies to outies, outies to, I think, and then innies to innies. So no outies because I don't know if we're using, oh, we have a couple of those. So we'll be going over that. Wire connectors, also been known as Wagos. If anyone's done any sort of electrical work in their house before, these are very nice and better than wire nuts. So these are how we're connecting certain wires together as well. And then we have cups of water back there, which we'll get to once we're done connecting everything. And then we don't have soil or coffee grounds today, but you can use that in the future when you want to transport this home, when you actually have a plant with you. We'll just be going from water to dry cup in this case. And then screwdriver, if you have your hardware kit with you, you'll have a screwdriver in there. I also have a spare here if you need to. All right. If you want to follow along on your own computer, we have our codelabs platform with the same stuff I'm going over today. And so codelabs.viam.com, you can find the plant watering workshop. And this contains, again, all this information to follow along with, including a link to these slides and a bunch of details to follow along. And this codelabs has many more of our sort of follow along step-by-step tutorials that we have available for building all sorts of smart machines. So to get started, because it takes a little bit of time, we're going to be starting with flashing our Raspberry Pi with our operating system. So unlike most other computers, your laptop, things you have, the Raspberry Pi doesn't come with any sort of operating system on it because it has no built-in storage. So that's why we have our micro SD card here. This is our storage. It contains our operating system, but it contains everything we need to run as a computer. Because we have to give it an operating system run. If we're going to do that, we're going to use our Raspberry Pi Imager application and be putting on Raspberry Pi's own operating system called Raspberry Pi OS. This is based on a Linux distribution called Debian and just has a lot of out-of-the-box support for its single-board computers. And so you'll want to take your micro SD card and reader, and then plug that into your computer. Yeah. Perfect. So when you have that connected, you open up the Raspberry Pi Imager, going to choose your device, which is a Raspberry Pi 4. And then the operating system is going to be the Raspberry Pi OS 64-bit. There's options for 32-bit, and there's also options for in other sort of menus for a late version, which is meaning it doesn't include full desktop operating system. And because we're not using this as a full desktop computer, you could choose the light version, but the desktop version will do just as well. And we're choosing 64-bit because most modern operating systems running 64-bit, they run better. VM can technically run on a 32-bit system, but we just have the best support for 64-bit systems.
Can you roll that again? So
Yeah, so when you open up the Raspberry Pi Imager application, you're going to choose device and choose the Raspberry Pi 4. And then for the operating system, you're going to choose Raspberry Pi OS 64 bits. And then for your storage, you should find the type of storage device you have connected to your
Is there a reason we use the Raspberry Pi 4 over? What is the difference with the 5 or the other ones?
So in the sense for VM, there really is no difference because we abstract over all of that and make it easy to work with. In this case, we have a bunch of Raspberry Pi 4s on hand. We have also a bunch of Raspberry Pi 5s on hand, and we're going through these right now. Eventually, when the new round of new hires come in, we'll probably have them using Raspberry Pi 5s over that. But the only difference really will be what you choose here and then what we choose in our VM app configuration, and that's nothing else will change. It's a little bit weird in our system right now in that the Raspberry Pi 4, Raspberry Pi 3, and Raspberry Pi 02W, just a whole name, all work off the same module, like the inside of the VM system. The Raspberry Pi 5 did something completely different with it, how it controls these pins on the board, the GPIO. And so that way it has its own configuration and module support there. But they're eventually going to be unified into one system. Just right now there's a weird sort of split there.
So you're talking about the generic storage device, right?
Should be available there. Cool. And then you hit next. And then when you hit next, we're going to be editing some settings.
Okay.
So you'll get the option to edit settings, and you'll be setting up, configuring it. So you can set your host name to whatever you like. In this case, I'm showing here, you can name it Planter. Make sure it's a unique name. Otherwise, they will, this is for finding it on the network. And so if they have the same name, they're going to clash and they're not going to be able to find them on the network. So, which is an issue. So make something unique, make it fun. Just remember what it is. And then set your username to, again, the sort of convention I go after is the host name, username, and password. I also do the same thing when I'm setting up a demo device, because that way I never forget. So as long as I know the name, I know the host name, and I know the password. For production devices, don't do this because that's not secure. But for this case today, it should make it easy to remember what's going on. And then for your Wi-Fi or wireless LAN there, you're going to be connecting to the Viam network, and the Wi-Fi password is all lowercase and it's one word. And then make sure your wireless LAN country is chosen as US, and then your locale settings set to New York and keyboard layout US. It'll probably default, if you've never opened this application before, to Great Britain, because that's where Raspberry Pi Foundation is from. And so they default all that there. And don't hit save just yet. We'll have one more setting to go through. Yeah.
So the SSID again was what?
The password, the SSID is Viam, and the password is lowercase.
Okay. Line country goes back to US, right?
Yeah. And make sure their locale settings are also set to New York and keyboard layout US. Keyboard layout is interesting because it can affect when you're typing in, and we're eventually going to what's called SSH into the Raspberry Pi, which allows us to remotely program it. And if you have a different keyboard layout, sometimes certain keys will show up differently in the terminal, which is an issue when you're trying to put in passwords and such.
/ New York and US. Got it.
And then you're going to go to the services tab there, and you're going to make sure that enable SSH is activated there. So as I talked about before, SSH, secure shell, is a way for us to enter the Raspberry Pi without having to be on like keyboard and mouse or anything connected to the Pi itself. Instead, we're going over the network. This is how you connect to a remote server somewhere. So because that's all the Raspberry Pi really is at this point. It's just some sort of server that we're going to be installing our own server on top of. And when you all are ready for that, you can hit save, and then you can hit, I think it's write or.
So would you like to?
Yes, you can hit the yes, and then you'll be prompted, and then hit yes again, saying that you're confirming when to clear it. You'll get prompted for your password or your Touch ID, in order to finish writing that. That's it. Now, while that's working, which can take some time, we're going to start with our hardware. So you can set aside your computer for a second and pick up your Raspberry Pi. I'll pass this all over to you when we get to the points. And so we have our single board computer. And so this is our brains for our robot. This is a collection of a chip on here, a CPU. We have some other connectors like we talked about before, USB-C, audio, USB, Ethernet. We also have these bunch of pins, and these are known as GPIO, general purpose input outputs. And so this is just a collection of ways of connecting, this to physical sensors. And these individual pins can do all sorts of things. And so you can see a layout here of what each different pin does. And so if you're holding it the way I am with the USB at the bottom, this is how the layout matches up here. So we have ones that are just for power. So when the Raspberry Pi is powered on, these have power running through them at all times, whether it's 3.3 volts or 5 volts. 3.3 is used in a lot of popular sensors. It's very common power outage. And that's also the peak amount of power that comes through the standard GPIO pins. The 5 volt is actually a direct line from are USB-C. And so 5 volt is the input you're getting from the USB-C port, and there's also output you can use to power other sort of components that run off of higher voltages. But you can also power the Raspberry Pi over those pins too. So if you don't want to use USB-C, but you want to power it from an external battery or some other power source, you actually power the Raspberry Pi from one of those 5 volt DC power pins. The other ones we have in black are the ground pins. Here we actually go to this next one. So ground is, so you have power as plus, you can think of it as, it's like we have power coming out. You want to eventually run all the power to a ground. In a lot of other places, ground is known as the earth, because eventually all power should go back to the earth, unless if you have open ground, usually causes things like static electricity or shorts and a lot of other things there. And so we have ground pins in order to complete our circuits in various ways. So you should always generally have if you have power coming into a board, you want to have power coming out of it in some or a component to a ground pin somewhere. You can have shared ground and all sorts of situations there. And then we have all sorts of other ways of communicating with our general purpose input output pins. So just the GPIO itself are what's known as digital GPIO, meaning they can only output a full amount of power or 3.3 volts or nothing. So there's no variable or what we call like analog pins available on this device. So if you have analog pins, which are also common on like microcontrollers and some other single board computers, they allow you to both output a variable amount of power or read in a variable amount of power, which is useful for some certain sensors that we'll be looking into today. And we have ways of converting that analog inputs to digital, so or ADC, so analog digital converters are available too. Other pins we have are I2C or integrated unit, or I2C, people often say too, is a very common communication protocol for talking to various sensors and other peripherals. SPI or SPI, serial peripheral interface, another sort of way of talking to peripherals. And these all vary on the amount of pins they use, other type of communications that they allow. We also have UART, or also known as serial. A USB, universal serial bus, is based on UART as well. It just has this nice nifty port for us to use rather than connect directly to the pins. But they all use the same communication pattern, whether it's through, again, the serial port or the pins themselves. PCM, pulse code modulation, is used for audio. So if you have some sort of like audio device you want to run off the pins, you use PCM. You're not going to run into too many cases for that on the Viam platform today, but it's available to you. Any questions before I move on? Cool. Oh, yeah, and here's an example of a GPIO signal. So like I said before, you have either 0 or what we refer to as 1, or 3.3 volts. And so when we have set a pin to 1, it means it's outputting the full 3.3 volts. We have it set to 0, it's setting 0 volts. And you can set that for any amount of time. This is showing how you could have it going up and down over what we call like a square wave, and because there's no variation or any sort of like curvature at all. It's all completely square. And this is the diagram we're putting together. This is all the components wired together. We'll go into each individual one step by step, but this is going to be the end product. That will be our full robot. And so starting off, we have our soil moisture sensor and our sensor module itself. So I'm going to hand this off to you all. You don't need to be powered on the Pi or anything in order to do this. And usually I tell people, don't power on your Pi when you're doing this, but we're going to be working around power pins and connecting stuff. And if you accidentally short something, that could break your device. And, you know, we can replace it, but also better to not to right now. Because if you have, ground or power mixed up, it can, break all sorts of components. Yes.
Do you memorize which?
No, absolutely not. No, so that's why we have those sort of diagrams like I showed before. Yeah, so this sort of stuff I look up all the time because I've never, I know some of them, like where the power pins are and where the ground pins are. Yeah. Some other single board computers will actually label them on the board themselves, which is helpful. For Raspberry Pi, they don't for whatever reason. But there's another link that I use called pinout, pinout.xyz, which provides the sort of mapping and all sorts of great resource that I use all the time. And so I'm going to hand over this to you all. And so that is our sensor module, and we'll be going through the different pins that we have here. And you'll be taking the black and white cable that should come with the sensor module and connecting it to the moisture sensor and the sensor module together. It doesn't matter which order those go in. Actually, I think there's no, that's the right one. Yep. Doesn't matter which, as long as it's just 2 pins to 2 pins. So you can see here we have 2 pins on the moisture sensor and then 2 pins on the sensor module. Just connect those together. It doesn't matter what order they go in, because the way the sensor works is by taking in voltage readings between those 2 legs. So when you should have, oh, sorry, it should be a black and white pair of outie or innies to innies.
Blue and gray.
Would that fit with it?
Yeah.
That's fine. The color doesn't matter, as long as the white, and
No matter which side we put them on, or
any order, there's no like clear ground or power pins between the sensor and the sensor module itself. And because all the sensor module is doing is taking in the voltage readings between the 2 legs. So it's going to put in some power over one of those lines, and it's going to try to read in power on the other side of the lines. And if it can't read in anything, it's going to get 0, because that's going to be and what we call
That's it.
you're going to actually connect that to the sensor module, which will be this. And so just the side of the 2 pins on it, and you'll connect those 2 together.
Thank you.
Yeah. And so when we stick the soil moisture sensor in water, water is a great conductor. And so the presence of water means that it can now conduct electricity between the 2 legs. And so that means it'll get either a full reading or a set amount of electrical readings between from the sensor module itself. And so that is what tells us how much moisture is theoretically within whatever you're sticking the moisture sensor into. When we're sticking a cup of water later, it should get us, you have water here. Like you have probably enough water based on that. And you can always tweak the threshold of the moisture sensor itself or the sensor module with a little screw top on the top of the module. So you can practice through that once we get through starting to control these with Viam. But yeah, the moisture sensor is basically the same way a leak detector works too. If you have any sort of leak detection in your house, as long as you have 2 little leads coming out, usually what we call them, into it be a bowl of water or somewhere that you may think of a leak might happen. As when water comes across those 2 leads, it means, hey, there's water here. It's letting you know that. So besides making, this sort of automatic plant watering device, you could make a leak detector. I did something similar when I was doing some plumbing at home not too long ago. And I wasn't too confident. It's my first time doing some custom plumbing. So I just stuck a leak detector in there or moisture sensor and then added it to Viam and got alerts if anything ever happened. Like, luckily, nothing did. But it was nice to be able to just set that up real quickly and have that peace of mind by just sticking it under my seat and having it work. And so from our sensor module to the Raspberry Pi, we're connecting 3 different wires. And these are going to be all innies to innies as well. And so let's see. All right, give you these 3. And so the way we talk about the pin numbers themselves is the physical pin number. So when I showed that layout before, you can see there's a physical pin number assigned to each one of these. So on the left side is all the odd pins, on the right side is all even pins. And so you could either look up that pinout.xyz application, that web page that I mentioned before, or you can start by doing 2, 4, 6, 8, start counting down, finding the actual pin number.
Diagrams for us.
Exactly, yeah, with the USB ports at the bottom. And so we're going to be connecting, so that pin 4 is the 3.3. Actually, pin 4 is actually 5 volts, so not 3 volts. We'll correct that.
You go back to the diagram for a second.
Yeah, of course.
Great, thanks. Appreciate that. Thanks.
So pin 4 is our 5 volt outputs from the Pi, which will connect to the VCC. Yeah, and you just kind of stab the any part onto the pin.
Doesn't matter which of you're talking about this one, right?
Yeah, and it could be any one of those pins, as long as you remember which one's connected, or any of one of the wires. So the color of the wire, and feel free to rip the wires apart if you need more space.
Got it.
Won't damage them. If you do damage them, we have spares. And the VCC is often used. We also see V in sometimes as well, and that's going to be our voltage currents coming into our sensor module from the Raspberry Pi. And so it'll be kind of small to see on the sensor module itself, but hopefully you have good eyes. If not, try to pull up your phone and maybe add the magnifying step there. And so the pin 6 is going to be our ground pin on our Pi to the GND or ground pin on our sensor module. And then pin 40, which is the very bottom of that stack of pins, is going to be connected to the DO or digital out from the sensor module. So there's also an AO on there, which is an analog out. So if you had an analog input reader on your computer, whatever you're connecting to the sensor module to, you could use that. But right now we only can read in digital inputs or outputs. And so you can also see the reference there, GPIO 21 is another way that we'll refer to pins on various computers and has its own numbering, even though it's, and all the stuff in Viam uses physical pin numbers just to make sure we're not trying to making sure it's somewhat equivalent across all the sort of computers that we are using and are supporting. Because GPIO can be all sorts of things. It could have a letter in it, it could have a number in it, could be all sorts of aspects there. Okay.
Almost there.
Yeah. Okay, great. And now we're going to be wiring our relay. We're going to start by wiring our relay from the Pi to the relay itself. And then we'll be connecting the relay to the pump that we have available here. And so you want to get out your little screwdriver because we're going to be connecting. So these are called terminal headers on top of there, the blue ones. And you have to unscrew them a little bit in order to stick a wire in there and then screw it down in order to make the wire stick in. And so from the Pi to the relay, we're going to have some innies to outies. And so we'll find those for you all. And so you'll want to find the side that says DC plus, DC minus, and in on the side on the relay. And it should be like opposite side of like the big blocky part that's on the relay itself. And DC plus is connecting to our power, in this case 3.3 volts or pin 1 on our Pi. And then don't worry about pin 2 for now. Pin 14 on the Pi is our ground connected to that DC minus on our relay here. And then pin 8 on the Pi is going to be connected to that in port on the relay. So no team.
What function is the relay serving?
So the relay is allowing us to toggle power connecting to our whatever component is attached to the relay itself. So in this case, is our motor pump. And so because the motor pump has no way of, it runs off of more than 3.3 volts, so we can't just connect it to a regular digital input or output. We need some way of toggling the amount of power that it receives. Since it wants 5 volts, then we want to be able to use a relay to say, okay, when I send you a signal, then you can toggle on those 5 volts that you get on. Exactly. And so a relay is often used for some of those entry point like smart devices you have in your house in terms of like smart switches, controlling lamps, all sorts of that type of thing. You will use a relay for that because they're going to take in more than what a microcontroller or any sort of other embeddable computer can output. So sometimes you'll be using these with something like 12 volts or more in order to say, okay, when I say so, toggle on whatever power you need. I've seen people embed these in things like a coffee machine in order to toggle on the power for running the coffee and running other sorts of motors in there. So relays are very common, very standard in a lot of sort of appliances, applications that you want to be able to control remotely or with some sort of computer. Yes.
We're taking these and putting into this one.
Yes, exactly. So you'll have your
Unscrew it.
you have to unscrew it. Yours might be unscrewed because I've been messing around with it. But so just try to stick the outie part of a wire into those normal headers. And if they go in, then it's unscrewed already. If they don't, unscrew them a little bit. They might be a little tough, so don't be afraid to give them some force in order to open them up. And then once you have them in there, then screw it back down and then give them a light tug to make sure that they stay in there. So they come out mid-operation, means your machine's not working anymore.
Okay, because I'm
Mhm.
picturing you screwing it in your stamp. That sounds so weird. But, okay, so if you plugged in the water pump to the 3.3 right on the Raspberry Pi, it would just be always on.
Yeah, for the
And then-
tree line, yes, it'll
Okay,
always be,
that helps like, yeah, the sensor data, then it's like the toggling point.
exactly.
Lovely. Just want to make sure I was tracking and not delusional.
And technically, this motor is a 3.3 or a 3 volt, 5 volt motor, so we could potentially run it off of just the GPIO pins on the Raspberry Pi. However, it'll run better and give more power. More power means more strength typically
Yeah.
for a motor. So you could, by having it 5 volts, it means we'll be able to pump out water from wherever.
And if it was running directly on the Raspberry Pi, would you be able to use that sensor data to toggle on and off or no?
Yeah, still.
Oh, okay.
Because we have that control part of it,
Yeah.
there's logic for when you want to toggle it on or off.
Okay.
So if you connect it instead of for the 3.3 volts pin, you can connect it to a GPIO pin, which can output 3.3 volts, and that you can toggle remotely with. Or
Okay.
toggle programmatically
Yeah.
through your
You
code.
could still have the same, but less effective.
Right, exactly.
Less reliable.
Mhm.
Got it.
Good question.
I have less free time right now.
Yeah, I know, again, the text can be pretty tiny on the relay itself.
Tighter, yeah.
Yeah, I think we need to,
Feel free to whip out a phone or anything if you need to magnify.
well, no, I know, but I have to tighten the one there.
Once you have the initial set of terminal headers connected for the DC plus, DC minus, and the in ports, you could then connect pin 2 or 5 volts on the Pi, another again, any to Audi to the I think it says 5 volts or let's see real quick. COM port, yes, thank you. So yeah, the COM port on the other side of the relay. And this is going to be, this COM port is the common power coming from that we'll use to pass through to the motor once we do toggle it through our code later.
So.
You give it a light tug and they don't come out, then you're good.
Beautiful.
And you want to connect the end of those to your Raspberry Pi as well. So DC plus to your. Sorry, I think I. Sorry, pin 1 is connected to COM, pin 2 is connected to your DC plus on your relay. And if this is
The top one is gonna be like 3.3. Here too. No, because the one.
Yeah, so-
Connected to the column, which is the other side.
yeah, so pin 2 on Pi is actually connected to the DC plus on your relay. And then pin 14 to the ground and pin 8 to the in port. And then pin 1 or 3.3 volt should be connected to the COM on the other side.
Where's the name COM coming from?
I believe it's either communication or common, if I remember correctly.
It's also the 5 volt.
No, the 5 volt is connected to the DC plus on the relay.
So the second one.
Second one goes
is
to
14.
14. Ground. Okay. Oh, Jesus Christ. 1, 3, 4, 5. That's a 7.
Yeah.
2, 3.
Yeah, the counting is always like one of the reasons that it can be trippy sometimes when you're trying to like, wait, did I skip one? And
Perfect.
yeah.
8. Yeah. Yeah.
Right, and then once you have, and then connect the pin 1 on your Pi to the COM port on the other side of your relay. And once you have your Pi and relay connected, we're going to go connect the relay or the motor pump to the relay and the Pi as well. And so that's where we're using these Wago connectors, these little orange connectors here. And these just allow us to connect 2 different wires without having to solder them or use a wire nut or any sort of thing there. You have these tabs on top that will take a little force to open them up. And then I have a piece of metal that splits the 2 sides there. And then so once you put wires in on either side and you close those tabs, it'll connect those two wires together over that piece of metal there. And so you'll open up the connectors and then you'll stick for the motor. You can stick the red wire into one side of there and push back. And this one's a little tricky because there's only so much exposed wire on the end of the motor there. And you'll push it into the end of the Wago and make sure that it touches the metal piece. So I often turn the Wago upside down so it's clear inside of there. And so I make sure that it's just around the metal part of the Wago, and then I'll snap it closed and then give it a light tug to make sure it stays in.
Too big.
Yeah. On the other side of the Wago that's open, take my Audi to Audi, because I have one going in the Wago and one going in the terminal header of the relay. You can push that all the way back because it can only go so far anyway, and then snap it closed and make sure it stays in there. And then you connect the other side of that wire to your relay. I'll have to go over this again if we need to.
All right, Nick, so
So you'll open up the tab, the top of the Wago and it'll take some force again to like open up those hooks.
So 3.3
just pull up.
to 1. Yeah, 1, which is the 3.3 volt.
Exactly, yeah. Yeah, and once you have it pulled up, so I usually flip them upside down because it's easier to see where the wire's going in.
Their
And
project,
so you'll
electricity with lemons.
stick the red wire of the motor into the open port of the Wago.
There was like all the little switchboards. Yeah.
Oh, okay.
There's only one open port. The other side looks like it's open. It's not actually. That's just clear.
Okay.
And then so you can stick the wire in there, and you want to make sure because there's only so much
So Wago he had.
metal on the
Like-
end of the motor wire.
This way or this way? Which way?
Yeah, you have it right there. It could be either side of the Wago. You can push it into. And so you can look at the bottom, you can see that metal piece that bridges the 2 sides of the Wago inside the bottom. And then make sure that the wire basically just comes past the bottom of that Wago, that metal connector to make sure it actually makes a connection or contact.
No, I'm really just trying to understand.
Sure.
So a little bit back, so you can see that little piece of metal potentially right there. So pull back a little bit, even more. So you want to make it just, there, and then snap the head of the side closed. It'll be a little tricky.
It's like right here.
Like now.
Yes, perfect.
You see a picture of it.
And then the other side, you can use an Audi to an Audi wire from your stack there, and then so you can peel off one of those, and then connect it to the other open end of that Wago. You can push it all the way through because it won't go past a certain point anyway, and then snap it closed.
Okay.
So you're gonna connect to the other side of the Wago they have open.
Okay.
Yeah. and then just stick the wire through there.
I was gonna stop. Take a video of it tomorrow.
It's supposed to come out the other side.
Nope, it'll just hit an end and then snap it closed. Because it has more exposed metal in there, so
Okay.
it's more likely to hit connection there. So now you can hit the other end of that wire into the NO, or normally open terminal header on your relay.
I think it's
So that's going to be, there's going to be NC, or normally closed, or NO, which is the one we're going to be using on the other side of the COM port on your relay. So the red and blue relay model that we have here. So this one.
there you go. Okay.
And then for
It's coming into
yeah,
this one here. Or?
it'll be the one.
So the Waco goes to.
If it weren't the same way, it'd be the bottom.
Says NO.
Yeah. And then the ground of our motor on that black wire, we're going
The
to
low cost.
also bridge with the Wago. Actually, that one's all done. You just need to connect the end of the jumper wire into the terminal header,
So we have to undo those. And then put this.
Oh, yeah,
or you could just bridge those. But we only have enough wires for.
it's fine.
You could do that, but you also need that spare wire for the ground one.
This one is easier. This one is easier. That's good.
And then once you have the motor and the relay connected, you're going to use the Wago to connect the other wire, open wire on the motor, to the pin 39, which is not pictured here on the Raspberry Pi, but it's right next to pin 40 at the bottom.
So
Yeah, these were on.
this one here, we're connecting as well with the Audi.
So that one's going to be
Okay.
so you're gonna connect that. So the black wire on the motor connecting to the Wago, and then the other side of the Wago there.
These?
So you have a
Oh,
Yeah.
sorry.
okay. And then once you connect, then you'll have a wire from the Wago, which would be an Audi going into the Wago, and then you'll have an INI connecting to pin 39, not pictured here on the Raspberry Pi. I'll go back to here. So
You ever see the movie Elf with Will Ferrell?
yes.
They're making etch a sketches. I feel like
Yeah.
etch a sketches. The head elf is going, "You're really slow." I'm like,
No, it's okay.
This is no, why we allocate 2 hours. This is honestly the I'll say the hardest part of doing this, because most people just don't familiar with and there's sort of that. Once we get into the Viam aspect of this, I promise you it's gonna just snap on by.
So on this one, like, so same thing again, this level, or I mean that way.
So I usually look at it this way just for be able to see the metal connector there. And so you want to push it just around to the end there, just to around where you can see it poke out past that metal part,
Okay,
and then snap it closed.
that, okay.
So if you all want to try that for the black wire on the motor as well. And then the other side of that Wago will be
Oh, this one?
one of the
Oh, God.
wires that has an Audi and an INI. And so the Audi will go into a Wago, the INI will go into the pin 39 here at the bottom pin stack, which is another ground pin on the Raspberry Pi.
Are we putting it in here? Or are we putting it in?
You're putting in its own way, yeah.
Oh, okay.
You gotta pull the pin like that to put this in the game,
Yeah. So
Love it.
like that. Or no,
Like doing.
yeah, so you can open that tab that doesn't have a wire in it. It'll take some force, yeah. And then just stick all the way back and then snap it closed. Yeah.
okay,
You actually want should have another
Yeah, the black one's sticking out there.
Okay.
should it say
Electricity.
Audi 2 Audi as well. Have a
It's in there and then the metal got to the wire. Really should have done that. Lemon, like.
we want to connect the other side of
I really
which
should.
here to the Raspberry Pi.
okay.
So
Really?
I figured out.
you'll connect that one into the Wago. and then the other end into pin 39.
It probably was, but you were sticking it.
No, I was just like
Yeah, so that's another one.
instructions, trying to make it light up with no sense of like how or why.
So now you should have your, so the other side of the Wago, you're gonna connect, do you have, you have a brown one? Yeah, so you can connect the brown one,
Got it, okay.
Audi part into the Wago, and then the any part onto pin 39. The Raspberry Pi.
Okay.
Okay.
And why?
So that's our ground. So like I said before, when we have,
As a loop?
yes, it's got to be a closed circuit for power to run all the way through. And so one part of the power is going to come from the relay into the motor, and the other part's going to come around to a ground pin on our Raspberry Pi. So that's pin 39 down here.
So I think you and I just removed one. There should be a wire connecting from that.
That's the circuit.
Yes, we should have, oh yeah, so we need this one.
Understand.
That I understand what would be a Judaism. Because like,
There we
if
go.
you celebrate Sabbath,
That's this one to here, and then the other side to the computer.
turn like lights off because it breaks a circuit. Yeah. That's a really helpful way to remember that.
What's an helpful way to remember?
On like Sabbath,
Hmm.
or if you're practicing like Orthodox,
Hmm.
you can turn the lights on because it breaks the circuit.
Mm-hmm.
It has to be a circuit. Everything has to be connected.
Yeah. And I know there's part of your
non-safe.
have a sort of like, there's some wire, like a line that runs around
Yeah.
certain portions, so you can technically operate within there without,
Mhm.
while still
There's
observing
stuff
that.
in place
Yeah.
or like light covers that people use. But if you're better with non-science things, it's good. It clearly works as a reference point for me.
Yeah. And you can also, if you're waiting, you can connect the silicone tube to the longer portion coming out of your motor or your pump there. It takes a little bit of oomph.
You got it.
How you feeling? How's everyone feeling?
Like I'm gonna take a hammer and smash it.
The second you start operating it remotely, it's gonna.
Sorry, was that too honest?
No, it's great.
Use like ISSH and
Yeah.
I've heard it used so many
Yeah.
times. I want to be that person.
Oh, what are we doing next?
So now, hopefully your micro SD card is finished flashing by now. And it should have some sort of confirmation prompt saying you can eject your micro SD card. And if that's the case, you can remove it from the SD card reader connected to your computer.
Or remove this one or?
Yes, you remove the SD card,
Alright.
which is in, sorry, I probably plugged it in for you already. So it's right there. Just pull that. And then you can plug it into your Pi. So on the other side of the USB-C stack, or USB stack, sorry, on the underside of the Raspberry Pi is the SD card reader. And you'll want to have the metal contacts of the SD card facing the board itself. And yeah, it's not going to bounce in or anything. You're just going to give it a nice firm push, and keep it in there. And then you can grab your power supply and then plug it in and power it on your Raspberry Pi. It will power on automatically. There's no power button on the Raspberry Pi 4. Come with a little toggle button on it.
It has to be plugged in to be functioning.
Okay, so for like remotely operating and it still has to have like power source plugging in.
Yes. Yeah.
What I do is that home needs to be hooked into my home.
Plug in your wall. You could USB-C ports. Yep. You could plug it into a battery because it runs off USB-C if you wanted to, and it could run for a certain amount of time.
Yeah.
And then press the button, make sure the light's on there. Yeah, great. So you should see a red light come on and a green light on your Raspberry Pi. The red light means it's getting power. The green light will blink occasionally, which means it's an activity light saying, hey, something's happening. It's starting up. This also usually indicates some sort of like network traffic if you're operating with it. Your motor may also start up depending on however your Raspberry Pi came out of the box. And that just means like those pins are getting powered. Like I said before, like some of the pins just are always powered. And some of the pins occasionally will boot up briefly and then stop when they, the actual operating system kicks in.
The GPIO pins are what we're considering motors. I think is that a synonym?
Say that again?
What's the motor? Is it the GPIO pins?
The motor, we'll be using GPIO pins to control the relay, which will then activate the motor.
Got it.
Yeah. There are different motor components in there. So yeah, I may use motor and pump, individually.
Okay.
Or like same time. But yeah, I'll usually be talking about like the motor in the pump.
Okay.
Because that's all it's really doing. It's spinning in order to move water as it's sucking in through another portion. So now you can go into the Viam app. Hopefully you've logged in, you have an account and everything, and you can add a new machine. You can name the machine the same thing you did for your host name or username, whatever you want to do to help you remember it. Or you can give it a unique name. You can call it Planter or whatever you want. This doesn't matter as much within your organization.
I have a question for adding new machines because I've tried to add my laptop as a machine on VM and I've downloaded Homebrew.
Okay, yeah.
Trying to get on that.
Mhm.
And it I was using what it's called, my terminal
Yeah.
on my laptop and could not get, I downloaded Homebrew and got Homebrew to install, but then could not get my laptop set up as a device on VM.
Mhm.
I was trying to do an image labeling workshop.
Yeah.
A, is that the right way to go about that? And B, why did we have to do that?
We're not doing that now because the VM server, which is what we're trying to, when you want to connect something to VM, we run VM server or VM agents. VM agent will install VM server for you and manage it and everything, which we'll be using today. VM server is the actual running process or application that runs on a device in order to connect to VM, manage configuration, manage all the connections to hardware and everything on your machine wherever you're running it. So
Okay.
if we were going to use the webcam on your laptop or be able to do something that runs on your laptop, we run VM server there. So if you're talking about the image classification stuff.
Yeah.
But in this case, we're running on the Raspberry Pi. So we'll be going over how to run or install VM server on the Pi.
Got it. Okay.
And I can
Circle
walk through.
back to the
Yeah.
laptop.
Yeah, so installing it on the laptop takes a little, on a macOS laptop at least, it takes a little bit more work because of the whole homebrew and things like that.
It was being moody. It was
Yeah.
code. I don't know why I didn't want to
It's slightly easier or more accessible, I'll say, on the Raspberry Pi, most because it's
Okay.
homebrew. It's just a simple
More
script.
Yeah.
Yeah, and so once you add your machine, you should see a setup prompt for the. I'm going to switch over to a different.
You gotta show me around or skip.
Oh, you really? Okay, so that's I would say skip for now. That's our getting started experience, like the sort of interactive walkthrough. Columns.
Yeah, I'm just waiting for the next instructions.
And so you'll see a prompt here to set up your machine. You can click view setup instructions. And you'll be choosing for the platform you want to run on is Linux Arch 64. And this is because we have our single board computer, our Raspberry Pi is a Linux device, our running Linux operating system on it at least. And we're using Arch 64, which is the type of architecture that the chip itself uses, also known as ARM 64 in some cases. So, macOS uses ARM, but a different flavor of ARM that runs on what we call a macOS or Darwin operating system. There's all sorts of other applications. You can look at all the different options that we support, including now Windows with some Windows support there. And then your installation method will be VM agents. As I said before, we have either the choice of VM agent or what we call the manual install of VM server. VM agent is what we're going to go through as the default mode for, and you'll see a script here for you'll copy. But first, you'll want to SSH into your Raspberry Pi. And so in order to do that, you're going to open up your terminal application on your laptop. It'll look a little something like this. And so you'll type, in order to find your device, or you can just try logging in directly. It should all be online. We may have given enough time. You do SSH, and then whatever the username that you entered for you're inside those settings that we were going through earlier during the Raspberry Pi Imager. So in my case, if I had named it Planter, the username would be Planter, and then the @ and then whatever the host name that you set to it as well. So like I said, if I use the same convention I was doing before, I could do planter.local. That .local is a local address that we can use to discover devices on our local network. This is actually how, like, if you ever use a wireless printer before, this is how they're discovering the network. They talk to the network and they say like, hey, I'm a printer on a device network. Here's my like path that you can find. So you don't have to memorize IP addresses or do all sorts of funky stuff there. Instead, you can just discover it through a more handy URL type of structure there. So once you have typed that in, you should hit enter. This is going to fail because there is no such device on the network for me to find. Yeah.
Is that again the username?
So it'll be the host name that you set. So if you follow the same convention that I was running through,
So it's
like, yeah.
Okay.
And you should be prompted for a password, or you should be prompted to say, do you approve this device? Secure key, something like that. You can hit yes, or type in yes and hit enter. And then you'll type in your password that you set for your device through that same configuration before. And then you'll have, hopefully, officially, you should see something on the left-hand side that says, like, again, username at hostname.local, and then some sort of like caret or something next to it. And that means you've now successfully SSH'd in to your device. That means now you're on the prompt or in the command line on the device itself.
Can I SSH in from my terminal onto this, even if we set it up to Camilla's
Mhm.
VM account?
Yeah, so any device that knows the address, username, and password for this can log in from the local network.
Okay. And
So-
what if you're at home and you want to check on your plan at the office?
Yep, same thing. Instead of using SSH, because we're not on the local network anymore, VMCLI actually has a shell service you can use in order to go into the device. You hopefully shouldn't need to, because you have Viam now to monitor and manage all the logs. This is how a bunch of people may have monitored devices remotely in the past. If you have a secure connection to your device, or you have exposed to the public internet, which is a little dangerous if you have enough security or firewalls around it, then you can still log in from wherever you are.
And if the device is set up on your VM account, you can still access all the information to it without SSHing into.
Exactly. Yeah.
Lovely.
That's the advantage we have here.
There we go. There's the point.
Yeah.
Nothing came up.
Nothing came up.
Yeah, I don't think me either, but I don't know if I'm good.
So I'm gonna use a handy utility that I have. What is the host name of your device?
Camilla X Shannon Plantbot.
Okay.
A little too long.
Shannon X Plantbot.
No, just been Plantbot.
Okay.
Plant pot.
It's unique.
It is unique.
No one's gonna have that name.
Oh, was I not?
No, I'm using this to find it. Interesting.
Can you try to ping it?
And I could have been.
I swear I think it's Plantbot.
Okay, let me try it again. I think it's.
Have you been able to find yours?
Yeah.
Okay. How about you, Larry? What's your name of your host?
Planter-bigcountry.local.
I love this. It's like
Big country like that?
AOL username.
Yeah,
Local?
local, yeah.
No, it's still like, so.
I think it's Plantbot. Does it say on your Raspberry Pi app?
Yeah, I don't know where to do that.
Take a look here. I'm not seeing any activity. So if you're not seeing a little flashing green light on your Pi,
Mhm.
then you can try all right, you can try unplugging it and plugging it back in. Hopefully that will kick it back into gear.
Flashing
Give it
green.
like a few seconds and everything to get started. And then you can try SSH into it again. I can do a little.
Type SSH and then space and the name.
Yeah, so SSH and then your username for the device, and then at hostname.local.
My terminal looks different than yours. Is that concerning?
Yeah.
Is it dark? Or is it?
It's not as concise.
Oh, that's because I have certain settings on my machine for development and everything. This isn't actually my terminal that I use. This I
Okay.
So you're typing in SSH space,
Yeah. So if you,
username,
what's your username? Do you remember? Is it still
Larry.Nelson.
Larry.Nelson at, is it Planter?
SSH. Let me see, Larry.Nelson. That's enter. I didn't realize you had to do the username.
The green still flashes.
Yeah, that's right.
I think you have to repeat it.
Could take a second for it to come online.
I did SSH, then space, then username, space, and then the planter dash big country to local.
Authenticity.
Oh, so it's gonna be at sign between them instead of a space. So you
Ah.
hit Control C to quit out of that if you need to.
A control C.
Yeah. And then
Okay.
Oh yeah. Okay. I think I'm going in.
So it's just
So-
the username and then at and then the name.
Wait, I was.
so yeah,
Oh,
so it'd be SSH your username at
I'm trying the same.
hostname.local.
Got
When you enter your password,
Mhm.
it doesn't show up for security.
Yeah.
I just entered it. Denied. Maybe it's
For the password.
that's the tricky part of not being able to see your password.
If you want to type it into a note or something and copy it and paste it, you can just to make sure.
still nothing.
That's the password, right?
Oh, so I found Miller one. Said it was planter-bigcountry.local. Or-
Planter dash big country dot local.
Option did not. Okay.
Right, what's your username for you?
Camilla Action. Plant pot.
All right, well, use my convention. That's good.
That's just everything you're gonna need.
Yeah.
No, is it?
I got that far.
Yeah.
Yeah, that should be the password. It should be the same.
You spell it. No, you copy and
No,
paste
'cause I
it.
copied and pasted.
So quick to blame you.
Did you use .local in your password, or did you just use?
No.
Yeah.
Did you try .local and it worked?
No. I use the same thing that logged in. So
Maybe I was having typos.
make sure your caps lock isn't on.
Yeah.
No, maybe I just didn't copy and paste correctly.
Okay, so maybe try SSHing again.
You sure?
I mean,
Yeah.
And so you should see a prompt like this, and you'll take that script line here. You can hit the two little page looking icon to copy it to we call your clipboard, and then you can paste it into your SSH session and then hit enter and should install Viam agent. And eventually you should see your
That's right here, right?
your machine come online and line up.
Yeah.
Right.
SSH. Wait.
And then when you're done with that, it's online. You should be able to just exit in order to close out the connection. Let me see.
All.
Enter.
Yeah.
Okay, now it's working.
Woo.
Yes.
We're still getting no activity for some reason. What this tells me, it might not be connecting to the network correctly.
Yeah.
Connected? Nice. What we're going
It's so
to
bad. I got things go right.
And this is all.
try doing is just
I have to
refine.
copy that line of code and put it in the terminal.
I'm like, I'm
Now
done.
now we're in.
Here.
And enter.
Did you copy the code from that page?
Yep.
Oh, yeah.
It goes like that.
Cool. That's fine.
And let's try going through the Raspberry Pi image.
Oh, it's giving a slide.
So once you've seen your machine connected, we're gonna go through and configure our Raspberry Pi. And so in the configure section of the application, you can hit the plus button next to your machine's name, which should be whatever the name you named your machine, dash main, and then look for the hit components, and then board, and then you can find the Raspberry Pi RPI. And so that is the Raspberry Pi board components for the Pi 4, Pi 3, and Pi 02W. You may also notice a Pi 5 one in there because consistency. And then you can keep the name as board-1 and click create, and you should see a card appear on the right-hand side underneath that plancher main. That is your Raspberry Pi board. And a board component is what represents, again, a collection of GPIO pins. So you don't always need a board component, even if you're using Raspberry Pi, if you're not using those GPIO pins. You only need it if you're doing some control over those. So you could have a camera, a motor, a bunch of stuff connected to your Raspberry Pi, but not be using those direct GPIO pin access. Instead, you're just using those abstract components, and you won't need a Raspberry Pi configured. But in this case, that's how we're going to be controlling our devices.
Does it work vice versa?
Did you confirm you have the? I wanted to check the network connection.
Like your motor is not configured.
So if you want to hit cancel right real quick, just to confirm. So next, fit settings and the general. It should be capital V, Viam, instead of lowercase. It shouldn't matter, but sometimes it does on Linux devices. And then hit show password. And then for that's just a encoded version that it does automatically when you configure it before. So if you want to clear that, just make sure again.
Or just stick it in your cup of water.
Then hit save. And then yes. Yes. And then confirm. And hopefully that'll do it. Yeah.
Chance we can take a break.
Yeah, of course. Yeah. And if we want to take a break real quick, if anyone needs to use restroom, if anyone needs to grab some water or a snack, I know lunch should also be arriving sometime soon. If y'all want to go grab that, you
I
can.
would assume ordered lunch.
Honestly, just successfully SSHing it for me. So
Yeah, we got that.
Yeah, if you do this regularly or you're trying to get into the computer a lot, then you can use what we call public-private key access. So is the other option in the Raspberry Pi imager is being able to use your public key, which means you don't have to use your password all the time, and it can also be more secure because you're the only owner of the private key that matches that. So that's what I'll often do if I have a bunch of demo devices, so I can remember the password for them. Which we have one password, which makes it easy, but like you can use a command called ssh-copy-id, and then that like network connection, Camilla X or Shannon plantbot at Camilla X local, it'll copy over your public private key or your public key over to the device, so then you can authenticate. And so when you do SSH next time, it'll just use that in order to say, okay, you're the owner of this device. But that does mean that if you want to have multiple owners, you need multiple public private keys copied over.
can't just private key with that.
Yeah.
Shared device.
You can have a shared device. Yeah. If you want to, be able to pet sit each other's plants.
We're gonna get a plan.
Yeah, it's good.
When I put it by the marketing window.
Oh, that's
Yeah.
great. Yeah.
We just have to get a plan.
Yes, that was, I talked about with Anna, I was like, how do we get plants as part of this workshop? But the idea of having a bunch of plants,
Yeah.
yeah.
Like it's
Sitting around.
Yeah.
So we think about like
You're earning
plants or
like
something really low end.
bunch of goodies on day.
Yeah.
Speak to.
And if we don't get to the new hire workshop right away, it's like when do we get
Yeah.
the plants around? And I'm sure we can work it out. I've been often thinking about trying to just grab some of the spare coffee grounds, so at least have something soil like.
Yeah.
But also then you can only wet them once if you want to keep trying. So for now we have glasses of water, and if you all want to bring over a glass of water and empty glass for some of the testing, you can.
Where is it source water actually from?
It'll be your cup of water over here. So you'll just dip the
Oh, the pump just
into it. Yeah.
It's gonna be.
So there's an opening on one end of the pump that will pull in water and then push it out to. Who's most trustworthy around?
Why would you do it like over my laptop?
Sturdy hand, kind of.
No, I thought you wanted to do the whole pumping.
Oh.
system. That's something that doesn't need to be.
No, no, that's for you. I just, yeah. Try with your coffee.
So when you have your board connected and you hit saved, make sure it's done configuring. You can check the logs tab if you want to see what happened after you're done configuring something. You see the output from your Raspberry Pi in the Viam server. And so this is pulling in what we call a module from the registry, installing that onto the Raspberry Pi and getting it up and running with the Viam server. And you can start to control your component from the control tab. And you'll see this board control card, we call it, that has also different sorts of fields, including a pin field, pin type, mode, and a bunch of abilities based on the mode that you set. And we can get started by controlling the sensor by entering pin 40 into the pin field there, setting the mode to read because you're getting input from that sensor. And then you can click the get button under that read pin kind of table there in order to read the value of that. And it should come out as low, I believe. Actually, it should be low.
I
Yeah.
got high.
Yeah. Okay. It should be. You're coming out as high or low?
Wow.
Low. Okay. It should go high if it's dry. Because that will indicate
I mean,
Maybe it's that.
we may need to tweak the terminal thing on your on there. So I'm going to do that. You can try turning the screw on the no on the don't stick it in there. The thermometer for the moisture sensor. The so on the sensor sensor and then the what it's connected to is the sensor module. So the little board there, you see the little screw top.
Oh, this one.
So that's your threshold setting. If you play around with dipping your sensor in the water and reading from that to see, if it comes back low, it means it's getting enough moisture. If it comes back high, it means that it doesn't have enough moisture and you're setting that cutoff. So here, let's keep going with you for a second.
Let's
So,
go.
okay. Actually,
turn
No, I know, but I don't.
yeah. And so try
on.
setting that up again.
Not connected properly.
Yeah, I mean, if you're getting some weird readings, just make sure that is all connected correctly.
All right, cross your fingers, Nick.
Yeah, hopefully.
I tightened it, but
It's
it's still low.
still low. Confirm the wiring. Okay, so right now we have our power should go into the VCC ground to ground.
It's upside down.
Yeah.
Okay.
Yeah, that's the thing with the visualization.
Gloss.
Yeah, so we have gray for power, white for ground. Hey, look at that.
There we go.
We have light. And now we have our digital out.
So we just did it
Or wires.
upside down.
It seems like it, yeah.
Yeah.
Yeah. So now you should want to read high if it's not sticking in water and then low when it's in water.
Try to refresh it.
And usually there should be two lights on the sensor module that are lit up. It depends on which kind you have. One light will be lit up when it just has power, two lights when it is past that threshold. And it depends on the different.
Good news, bad news, Nick. Lots of green flashy lights.
Well, you still give it a second because the first boot takes like a solid minute or so.
Oh.
So we'll give it some time, and we'll just keep periodically checking in. So,
That,
I'm almost thanks.
so that's just,
Looking over here.
Not just salad.
Yeah, I think I have something in the wrong.
Mediterranean bowl.
Oh, okay. I haven't had very.
Kale we had golden
I think I had ground and
really excited when I saw it.
swap.
Okay.
Black lentils, feta, chicken. The rest is just like nice. It's like what I like. So we get a-
And if you have successfully read from your sensor module, we can look at controlling the motor or actuating. You can select pin 8 in the pin field, set the mode to right, and then you can set the state to high, and then click set to write that state to the pin.
Still says low. Oh, you have to loosen it?
It depends on like which
Oh,
direction you're
there's-
going. So yeah, so this is going to basically, if we go push it all the way or past a certain point, that means like if no moisture is coming in, it's always going to read it's like, oh, there's plenty of moisture here, even if it's in the air or whatever. And you can tweak it to say like less moisture.
So that directly impacts how sensitive it is.
Yeah, so this is like
That makes great sense.
it's using what's called a resistor inside of there. Or
Oh, no, it's so high.
yeah.
Yeah.
So, and you'll see again that light come on when it, so, and it's high, the light is off. If we get it down to
There we
a
go.
low. So now also, we just get just past there and you
Perfect.
dip it in some water, you can see the
Yeah.
light's on. Now it's low.
Yay. Okay.
Pull it out.
Sweet.
Amazing.
Well,
And we'll be using those values as part of full code later on.
What are the odds that I fried it because I had the voltages swapped? Because it's kind of just like stuck.
Oh, something slightly likely. If it just doesn't ever turn off, then
Yeah,
that could be
I
likely.
may have fried it.
Which happens. Unfortunately, we don't have another one right now. So we're working off a theory, but I mean, it being high means it's going to just always have the motor run, or it being set to low, it'll always just run the motor.
okay.
One of those.
Yeah.
the
Yes.
connected,
Okay.
Very
I
helpful.
said yes,
Mhm.
something that was there, it's turning.
Yep.
How do you?
Now, remember the password you said.
I had like the night.
So just type that in, or if you are not sure about typing in without seeing it,
Oh,
you can type it in like a notes document. and
I got it to 3 chicken.
If you can remember it, just type it in, and then hit enter, and you should get.
Tonight, my well broth that I spent 6 hours making last night.
Indeed, I did.
Yes. So now you'll go.
It's no, it says connection closed.
And
Okay.
my goal is to make 7 meals from 1 row to 3.
All right, try pushing the up arrow.
They're like
That'll
that.
bring,
Like if we go up to tonight, that's 2.
that'll bring this command again and hit enter.
3 chicken.
Same.
I started.
Right, second.
at 6. I went to, I had to teach.
They just type it in.
Yeah.
I went to Pilates, got my nails done, whatever. And it simmered for 6 hours. This is when it started.
Oh, there we go. I think it was just had been waiting too long.
Celery.
Now what?
So now in the VM app, once
Flowers and.
you see this command here,
Yep.
Yeah.
icon there,
Right.
copy to your clipboard, and then paste that into your prompt.
And then I strained it. And now it's sitting in my fridge and I checked it this morning and it got gelatinous, which means I did it right.
So run do some stuff. If you look at the VM app, when the you get
I did so many pictures of it, so.
indicator. I think that's-
Rotisserie chicken. That's
It'll take
insane. It tasted so good. I finished it like 11.
less than a minute.
I tried it.
5 minutes.
Yeah, I had the night.
So to control your motor, you'll center for your pump.
That's the Bone Broth Company.
Set it to pin 8. Keep your or set your motor right, and then set the pin state to high and hit set, and it should turn on the motor. And you'll hear that little buzzing. You hear a click for the relay. You'll hear a clicking relay, and then you should hear a buzzing from the motor, and then you can hit toggle the SIG back to low to turn it back off. So let's burn it works for you all.
So,
All right, looks like it's on. Let's see.
Relay.
So
Do you click
live
live?
now.
Quick set.
Yeah, switch it to right.
Machine is connected.
Yeah.
And you go proceed to the
Yeah.
config tab,
got it.
and you'll be going and hitting the plus button. Next
Probably the
to
wire.
name, the machine name there, hit components,
And
board,
Wires.
selecting the.
which wire would it be? The motor?
RP.
Do you think?
And
Uh,
it's supposed to be pin 8.
Yeah.
Which one?
Oh,
RPI.
like, yeah.
It's right here.
Yeah. And so there's another one's for like
Yeah.
a Pi 5. So if we're using regular Pi 5, it's
Oh,
green one.
I
Is it the green one?
And then you-
Yeah.
Do you think this is just the date in here?
and then
Should go on more.
keep the name as it is and hit create. And now you have your board component section.
All the way in.
You can either do Command S to save or click the save button.
I don't
Yeah.
want to disconnect it.
Yeah.
Got it.
And you can look at the logs tab if you want to see, so it's,
We get some troubleshoot.
to see like what's happening after you hit save to see, right, here's the logs coming back from my computer when they're running high
Wow.
as it's setting stuff up, as it's downloading the
The
module.
goal is to make it as common as making bone broth.
Go to the
I
control
don't think
tab
that'd be common for me personally.
and provide, which may take a second to come up as it's still setting up like the board component and everything. You can go to the logs again to,
I'm gonna get little so I'm gonna get like
A broth store.
there's a
A
butcher
broth
near me and I want to get like the bones.
still, okay, it's still going through. When you start to see,
One with cinnamon.
robot reconfigured logs, it means it's successfully
Okay.
finished that. It may take a second to come in. Yes.
It's not working for us.
Oh, let's
Question is, this wire maybe isn't
confirm.
as good as they should be.
So we have our PC plus minus, I think we have software ground and our in. So in should, oh no, never mind. Pin 14 is ground, right? And then 8, 2, 4, 8.
Is it on the one over?
We're just. Yeah, we're one off.
Okay. There we go.
Yeah.
I'm not looking at you.
Alright,
Okay.
Oh, I see. Okay.
Or should this be tighter?
so you can see the. Light
Yeah.
coming on there, so it's getting activated. We have something probably loose
In here.
in here.
We are wiring.
Okay, yeah, this is one of the common issues with the Wagos because, and the little motor wires here, because it's so,
Have to touch the back.
I use the wire cutters to get more.
get more, yeah, because you can see there's only so much
Yeah.
like metal coming out of that. We
And
want
it
to use
needs
to
to
touch the
touch the
metal.
metal.
Yeah, up
Okay,
here.
I was convinced it was just a little hub of electricity.
And then you can practice putting the pump into the water and then turning it on and make sure the other side of the, so put the pump aspect of it or like into the, submerge it into the water. Yeah.
With that configured.
Excellent. So actually go to the control tab.
Yeah, drop it.
Yep, drop it in.
Okay.
And then, yeah, stick the other side into the empty cup and then run it and see, watch the motor or the pump actually pump out water. So,
Holy shit. Look at you guys.
there you go. So you can do the same thing now. So watch.
Okay.
So you can, enter pin 8.
Too much, no.
You
Yep, and then you can hit, everything else is configured correctly, so you hit set.
work.
The set there.
So
We should turn this. Just. Well, that's not connected to anything.
it's actually connected to something.
Should be, yes.
Oh, that's what was it. Yeah.
This one should be connected to 3. There we go. And so if you hit, so this is out on, so if you set the state to low, and then it sets, it turns it off. So that's when we're toggling now,
Yeah.
our relay. So you hear that click in the relay,
Yeah.
passes power through.
Pretty cool.
And so if you submerge this with the tube connected to it to glass water, get us out tube into empty glass. You'll now kind of a remote controlled water pump there. And as we said before, you can adjust that notch on the top of the sensor module to based on
Drop that down
how
there.
you get and how much moisture I should receive in order to say, okay, this is how we'll say when it should be high or should be low and when to start watering. But right now we're doing this manually. So
Holy shit, look at that.
it happens. There we go. See, I told you, once you get there, it feels great. But you don't want to be checking.
$1 million, please.
Yeah.
Fine,
We want this to happen intelligently, use
Yeah, let's
the sensor data to be able to automate it. And so we're going to configure a service. So we talked about components before, and now we have services. Components are usually a one-for-one match for what we've talked to, like physical components, whether it's actuating component or reading from sensor data, and for physical hardware, I should say. And then our service is be pure software. And so that's going to be combining in and taking in the data from our sensor and starting to activate the pump based on the sensor feedback, whether or not it's been set to high or low, based on how you've toggled that threshold of the sensor module. And so our what we're calling our water controller service, you can see the code there if you ever want to take a look at it. It's written in Python. And it pulls in GPIO data from the board and then use GPIO to activate that relay or switch. And so you can go back to your configure tab in the Viam app and click the plus button again. You're going to hit service, look for generic, should be near the top. I think there's a second generic in there, and so like be careful with that. And look for the watering controller : plant watering. In this case, I named it watering because naming things is hard. And hit create, and then we're going to do something before we hit save. Though.
Well, do you hit add module or what?
Add module and then create. Yeah.
And then create?
I'm sorry.
And you'll get that again, another card below that board card that we have. And just to say something like the name, whatever you named it watering, it'll be that. It could also be generic one if you didn't change it. And then we're going to configure it with this JSON format configuration. This is basically how all components are configured under the hood. Sometimes they give you what we call a fancy config or UI on top of it. Sometimes it's just this sort of more bare bones JSON configuration, and you're going to be setting this field inside those curly braces. So it'll be double quotes board _ name and double quote : and then in double quotes board -1. If you renamed your board component to something else, put the name there. This is just telling our watering controller service what the name of our board component is, so it knows how to talk to it in our machine configuration.
To type it in.
Yeah.
And did you do it in quote?
You go down to line 2, type something.
Mhm.
I want to take it out of the quote.
I think I did cool.
Are you doing the quotes or not?
It's
You do the full quotes or?
beautiful. Yeah. If you don't format it correctly, the editor will warn you with some sort of like red squiggles or warrants to say like, hey, this is configured incorrectly or it won't be a proper JSON format, which is helpful. Just doesn't tell you how to fix it. You have to figure that out for yourself.
I've noticed that with the terminal.
Yeah.
It's like wrong.
Yeah. Fix it. I'm not going to tell you how.
Did they code something that tells me when my code is wrong? Alan kind of did.
You can a little bit. Yeah, there's a bunch of things out there.
She's way more talented than me to do that first.
There's a whole thing called language server protocols that allow you to have this sort of feedback inside your editor.
Okay.
So once you've configured that and hit save, it'll go to, you can look at the logs again and see it, download the module and get everything set up. And when you start to see robot reconfigured at the top of your logs, it means it's now successfully reconfigured, and we can, it should automatically start the service. And so what that service will do is if the sensor reads as high, because it's now high and drives, like I like to think of it, it'll toggle on your pump motor in order to start feeding in more water until it reads as low. And so if you have your sensor out of water, it means it'll keep trying to feed it until you put that sensor into water and now set it to, yeah. And now it should automatically turn off. There you go. And so if you were to put this in soil and it starts to go dry, it should automatically start for you as soon as that. And again, you can tweak it over time. And if you ever need to stop it because like if you need to transport it or something like that and it's running or it's powered, we can go over into that control panel again. And that control panel should have another card now for your watering service and a do command section underneath that. And in the JSON format for the do command, you can do a double quotes stop and then colon and another double quotes, and that will now command it to stop that service. And then you can use start to restart it in your own.
Double quote stop.
Um,
You said?
yeah, double quotes stop, and then after the end of the double quotes, colon, and then more double quotes, and then you can hit execute on the
Right.
I want to see what.
so execute on the button.
So just, do I do stop again though?
Just like that, it's just fine. And then that
Quote stop, colon, double quotes.
should stop it. You hit the logs, please. Then you just stop talk. But you also see some of the logic coming out from the sensor control
Yeah.
there of how it's trying to
Currently watering? Sure.
yeah, currently water and how it's reading and it's stopping. Yes.
Still plugging along.
Mhm.
What am I supposed to see?
So when the sensor is out of water, it should automatically. Yeah, this is the same thing as.
Start it.
So.
Okay, so that works. Okay, now try stop. And it has to be an input line too.
Oh,
No, now it's automatically running. So if you stick that into some water, it should automatically stop.
Stop. But it starts.
There we go.
So then how did he stop?
that's cool.
You went to. No, not to logs.
And so we're starting to wrap up here. You have an automatic watering device. Now what? So it's quite the collection of hardware you have right now, but this is just the beginning. So if you want to follow up, we'll have office hours as well for new ideas. You should also have gotten a like webcam as part of your kit. We can work on adding webcams so you can have actual video remote monitoring of your plant water device, start to capture image data, and maybe even start to train an ML model about is the plant healthy, is it not healthy? When should you add more into that as part of the logic of your controller control loop? If you want to add different types of sensors into there, like a temperature sensor or humidity sensor, to be able to add in even more data as part of, when should you be watering is different seasonalities of it as well. So because maybe the moisture is dry right now, or maybe you pull in weather data, you can pull that in and it's just pure software and say, okay, local weather data, I'm expecting rain. And I'll just stick my device outside with some protection for the electronic components, but you can start to take in all sorts of other aspects of the world and integrate it into your now automated robot. If you want to, maybe not do the plant watering device and maybe make a mobile robot or build something completely different, we can work on that together. So this is just your first step in a long journey, hopefully, starting to build out robots and smart machines and be able to automate the world.
Thanks, Nick. This is awesome.
Yeah.
So.
And yeah, of course, check out the docs, check out if you want to join Discord and see what other people are building there, or more of our code labs that we have, and we're continuing to build those apps too. And if you ever have any questions, you know where to find me, hopefully on Slack. And happy to answer any of those questions. Anything right now I can answer in the last 7 minutes.
How do we disconnect this?
Okay.
Like,
I mean, you can just power it off. It'll keep
Okay.
fine.
and unplug
You
it.
can unplug it. You can use the little button on your switch there if you just want to toggle it off. And then, you can transport that however you please to wherever you're going.
Let's go with the LinkedIn post.
Heck yes.
Technically, I built a robot today.
You did. Yeah. You built a robot. All three,
Thanks
four,
for it.
four. You did. Yeah.
Fuck yeah, I built a robot.
Take a picture of it. Don't apologize.
Even now, after doing this for many years, every time I get something running, every time I make a light blink, it's amazing. I love seeing it happen.
Now, technically, you did have to move the wires around to have those messed up.
That's one simple thing. It's like the one thing that like it's either wiring or it's hardware more than it is going to be like your code or something.
I SSH into my video intercom system in my apartment. I've talked
You
to
can
Elliot.
install VM on it, yeah.
I've talked to Elliot about installing VM on it. And apparently at the original VM office, they did that.
Yeah, they did. I remember that, hearing about that.
Yeah, I need to like figure out how to do that without getting in trouble with my board.
That is, I knew someone who basically made like a homemade like video doorbell that way of like installing a bunch of components at like the front, even though it was like a shared apartment building.
Oh my god.
Yeah.
I don't want to get thrown out. I love my role
Yeah,
class.
that's the one problem with it. It's like the way we kind of
Like,
control.
no,
like,
at
where
first,
it's at.
this building is like 80 to 90
Are we
plus.
still being recorded?
So we would
Okay, I'll,
I'm gonna know. Then he's not gonna find out. Oh yeah, thank you.